Hello everyone, in this video we are going to see about the implementation of stack data structure using the C program, and the implementation is done using the linked list concept. What is linked list? Linked list is a data structure in memory where every component is the collection of the linked list is a collection of nodes, and each node consists of a value and the connecting point. Okay, now let us see. First of all, how the program starts. Include stdio.h, the standard input output library, and then hash includes stdlib, which is the standard library we are going to use in the program, which is the header file, and then we define a node, because we have seen that linked list is the collection of nodes. Each node consists of an element and the pointer. So what is the element? That is the data, and pointer is the address of the next data. Using this next address only, the next element is located in the linked list concept. Whereas in array we have continuous memory locations for the data, but in the case of linked list, the data are scattered all over the memory and it is located using the pointer variable. Okay, so now after defining the node data structure, we are declaring a variable called star list. Star list is the pointer variable. Okay, and initially we assume this is null because there is nothing in the linked list. Now it is the empty list, so we are using the null as the initializing value. And now we are defining using the type def struct node stack. That means we are defining a stack of type node, and that node comes under the structure type, and it is defined using the type def function of the statement. So this is the way how the stack is represented in the memory. So we have the empty stack, and then we push the value. Push is the operation to insert value into the stack, and pop is the value as the function used to remove the value from the stack. So push inserts the data and pop removes the data. When you push the data, it is put in the top of the stack. So there is only one entry and one exit, the same entry and the exit, so which is the last in first out data structure. Okay, so this push helps to insert data. When you push, it is pushed into the stack, and when you again push, the next element is pushed on the top element. Like this, how you put the stack, okay, the stack of plates in a plate holder. Likewise, the elements are put one above the other. And same way, when you use the pop function removes data from the top of the stack. So when you give pop, the top element is removed. Again, when you give pop, the next element is removed. Okay, so this is how the representation of stack in memory is given. Okay, now let us see the functions which are used to perform the stack operations. Is empty. What is empty? Is this function checks whether the stack is empty or not. Next, void push int of e. This function helps to insert the element e into the stack, onto the stack. Next one is void pop. Pop removes the data element from the stack. And then void top. Top shows the current top element in the stack, and display function displays the elements in the stack. And same way we are having the, so let us define the functions one by one, and first let us define the main function. So what is the main function here? The main function is the program which is going to display the menu driven choices for the operations. For that we declare two variable integers ch and e. Ch is used for choice and e is the element. Okay, now let us start the do loop. This do loop repeats again and again for the choices 1, 2, 3 and 4 to insert, delete, display and find the top of the element of the stack. So do the open brace starts, and then printf push pop top display and exit, which has the variable values 1, 2, 3, 4 and 5. If you give 1, the push is called. If you give 2, pop is called. If you give 3, top is called. And if you give 4, the display function is called. And if you give the value other than 4, it will exit out of the program of the loop. So the loop starts like this: print enter your choice, and this is the printf statement to get the value for the choice, and scanf really reads the value of the choice. Scanf %d ampersand ch means we are getting a value in the variable ch and this is the integer data type. So percentage %d is used as the format. So now switch case statement, switch ch, the case starts here. So now how you form the program is, for case 1 we call the push function. Okay, so enter the element to push. So now the element is red, like we have seen in the last diagram. The element is pushed when the element is received from the user and pushed into this onto the stack. So once you receive the value from the user using the scanf function, and this push helps to insert the element onto the stack. Okay, same way, so every break in the case will take the control out of the case, respective case. Okay, then case 2 we are saying pop, removes the element and then break. Likewise case 3 it is top, it shows the top element in the stack and then break. And case 4 is display, it will display the element on the stack and then it will break out of that case. And finally the do loop is closed and with the condition while ch less than or equal to 4. So as long as the values are 1, 2, 3 and 4, these functions are performed, and when the value is beyond 4, this will come out of this do loop. Okay, so return 0. Return 0 returns 0 to the operating system because the function is int main. Void main means we don't use this return 0. If we use int main, we use the return 0. Okay, so now let us see. And now the main program is closed over here. Now we have to define all the functions. Initially we have declared all the functions, push, pop, top, display. Now we are going to define the function one by one. So let us see one by one the functions. First is empty. What is empty? Is empty check whether the stack is empty or not. For that it has this statement, if list is equal to null, that means the list is equal to null means that is nothing in the list, so return 1. So we can say that the stack is empty, there is nothing to. So for this case the list is equal to null. Okay, return 1, else return 0. So if the stack is empty, 1 is returned. If the stack is not empty, 0 is returned to the main program. This is the isEmpty function to check whether the stack is empty or not. Why should we check the stack is empty or not? Suppose if you are asked to pop the element, we cannot remove the element from the empty stack. So we have to, before removing using the pop function, we have to check whether the stack is empty or not. Okay. And now the next function is defined push. What is push? Inserting element to the stack. So we are getting the parameter integer e from the main program. Okay, so now the void push starts. Now we are creating stack new node is equal to malloc size of stack. This is the memory allocation line of the program which allocates the memory area for the stack based on the size of the stack. Okay, so malloc is the function, size of is another function, the stack is the data structure. It creates this much space using the malloc, that is memory allocation. And now this is assigned to the new variable new node, because every time you push your node you have to create a new node and insert the new element. So we are using a variable called new node, which is a pointer variable because we are using the linked list concept. Okay, and now new node, this arrow is the says it is the this is the part of the element. For example, new node consists of two. I told already in the previous slides, every node consists of element and then address. Okay, so likewise here new node arrow means element is equal to e. That means new node contains the element e to be pushed, and we have to check whether the stack is empty or not. Okay, and then if it is empty, we have to create a new node of next is equal to null, because initially when the stack is null, that is when the stack is new means there will be nothing in the pointer. Okay, so if the stack is empty, new node of next is equal to null. Okay, else the new node of next is equal to list. So that means when after pushing an element, if it is the last element means the pointer will be null, and if it is the in between element means the pointer will be list. Okay, list is the type of the node. Okay, and now list is equal to new node. So here this new node is created using this malloc function, and that is attached to the list. Likewise, every time a new node is created, it is added attached to the list to form the complete linked list. And now this function is closed. Okay, and same way the next function pop, as we have seen earlier, pop is the function to remove the data from the stack. So how it will remove? It will check whether the stack is empty or not. If it is empty, it will give the message as the stack is underflow. I cannot remove element from an empty stack. So else it will remove the element. How it will remove? It has to remove the variable, both the value as well as the pointer. So how it will do? Stack of temp node. A new node is created under the stack data structure, and the temp node consists of two elements as usual. So the temp node is equal to list, means whatever the top element is shown, which is the list, that will be assigned to the temp node, and list is equal to list of next, means this will help to point to the next consecutive element in the stack. Okay, that means after removing one element, the list pointer should point to the next element. Like when we say in the array concept, pop is equal to pop minus 1. When you are using the pop, you always say top is equal to top minus 1. Okay, for that we are using these statements to decrement the top variable of the stack, and then you print the element, because once you pop, you have to display on the screen, so you have to display only the element. So top temp node of element, we are just declaring, or we are just displaying only the element, the value, not the pointers. Okay, and now free of temp node. So once you pop, okay, once you are going to push, we are going to create a new node. Once you pop, the node becomes empty and we have to free. Free is the memory function which frees the memory area occupied by the particular node. So if you remove a node from the stack, the memory area has to be released. That is done by the free function, and it is closed. This is the pop function which checks, it removes the value if it is available. So this empty is checked, the stack is empty, nothing can be removed. If the stack is not empty, it will remove the data from the top and store in the temp node, and the temp node is freed. The memory area of the temp node is freed. And now next is the function which is top. Top just indicates the top element of the stack. So again it will check whether it is, if it is empty. If it is empty, means the stack is underflow, and else it will say, it will just display the element from the top of the stack. So here is the, when you say top, means this 6 is indicated. After removing this using the pop, if you say top, means now 5 is the top. After removing this pop, when you say top, means the top is equal to empty, which is the empty stack, which is an underflow. We cannot remove element from the empty stack. Okay, else print list arrow element, means this will just display the top element of the stack, and now the braces are closed. Okay, so we have just given the top function, pop function, as well as the isEmpty function. Now let us see the display function. What is this display function? It will just display the elements of the stack. So how to display? Again, we cannot display the empty stack, so it is checked using the isEmpty function. isEmpty function says that if the stack is empty, the message is given, the stack is underflow, nothing is in the stack, I cannot display the values. Otherwise, it display the value from the stack. So how it will display? It has to display the value as well as the pointer. So stack position is equal to list. That means stack is the data structure we have defined using the node structure, and position is the variable we are using to denote the consecutive elements or the components of the linked list. Okay, so now position is equal to list. We are just pushing the value which is assigned from the list to the position. Okay, and now while position not equal to null, means there is something to display. that is, if this is not null means there is something to display, it will keep on displaying. So how the display is done? For they have to display the element. So printf %d slash t, this is for tab function, it will give 5 spaces in between the elements, and then position arrow element. So the elements are displayed on the screen, and next position is equal to position arrow next means, can we say top is equal to top plus 1 in the case of array concept. We are using this position is equal to position arrow next, and now we have to close the while, and then we have to print this slash n will give the new space to print. So actually what you are doing in the display is we are check whether the stack is empty. If it is empty, we cannot display, just to display the message underflow. If it is something is there, we have to display the elements one by one using the while function. So in the while loop, first display top element of the stack, then the pointer is decremented or incremented, then the next element is displayed. Likewise, the consecutive elements are displayed from the stack, that is the display function. And finally we have the output screen. So here you are giving the choice. This is the same as the previous one I have done using the arrays. The concept is, since the concept is same, only the data structure is different, the output screen is also the same. So when you give 1, it will push the element, because 1 is assigned for push. So when you give 1, it is pushed. Okay, so it again we keep on giving 1 1 1 1 1, and we are pushing values 11 22 33 44 and 55, because we are defining stack value as capacity is 5 in the case of integer value in the array concept. But in the case of linked list, we need not define, we cannot define the size, because the size goes with the pointer. Okay, so just we are assuming that we are having the null pointer in the 6th position, and it says that the stack is overflow. Only this much can be attached to the stack. And now pop, the choices are given. So when I give 4, it will display all the values 54 44 22, all the things inserted into the stack. And again if we give pop, 2 is the for pop, so it will remove the top element, which is 55. Again you give 2, now top becomes 44, because 55 is removed already, then 44, then 33, then 22, then 11. So if we keep on trying to pop more element, it will say the stack is empty, underflow, the stack is underflow, I cannot remove more element. And now if you give the choice as 4 is to display, since nothing is there, it will say stack underflow. Likewise, we can use the choices alternatively 1 and 2 alternatively. If you understand the concept of push and pop and display, how it is using the top element, we can just give any choices and we can see how the stack grows and shrinks. And finally, if we want to come out of the stack, we are using the any number other than 4, 1 to 4, and then we exit the program. Okay, so this is how the simple concept of how the stack is implemented using the linked list concept. The same program you can see in the last video using the array concept. You should know the difference here. What is the concept is actually the stack consists of push, pop, top and display functions only, but inside the memory the stack is used continuously, that is called as an array implementation. When the stack element are stored using the linked nodes, that is called as an linked list concept. So this is how the stack operation is implemented using the C program. Hope it is easy to follow, though it is lengthy program. First you should be able to understand the concept of the stack and the concept of how the pop, top and the push works. And thanks for watching.